Who would have dreamed that the introduction of a new application of concrete to American construction would become the foundation of 50 years of human daring, risk, and innovation? Who would have imagined that the 1950 construction of the Walnut Lane Memorial Bridge in Philadelphia would so dramatically change the thinking of American engineers and designers? No single event was more instrumental in launching the pre-stressed and precast concrete industry in North America. And no person was more significant in making the Walnut Lane Bridge into a reality than Professor Gustave Monniel of Belgium. A charismatic, dynamic engineering genius, Monniel developed the concepts for pre-stressed concrete while at the University of Ghent. He brought his ideas to America during a visit in 1946. Charles C. Zollman, a former student and a Pennsylvania consulting engineer, worked with Monniel, and together they outlined the benefits that pre-stressing would provide to concrete components. Their report led to the testing of full-size bridge beams developed by Monniel. Zollman then worked with Ted Goot of the Preload Corporation and officials in Philadelphia's Bureau of Engineering, Surveys, and Zoning to create a design that took full advantage of pre-stressed concrete's benefits. Bids for the project were taken on January 19, 1949. The contract was awarded later that spring to the Henry W. Horst Company in the amount of $698,000. Interest in the project was extremely high. More than 300 engineers from 17 states and 5 countries watched a test of a girder like those used in the Walnut Lane Bridge's main span. The project proved to be an unqualified success. The Walnut Lane Memorial Bridge met a variety of challenges and proved that pre-stressed concrete could provide benefits unmatched by any other material. It was the culmination of many innovations developing around this new technology during this period. For instance, as early as 1944, the first technical committee on pre-stressed concrete was organized by ACI and ASCE. Then, in 1948, the first stress-relieved wire was developed by John A. Roebling and Sons Company. And in 1949, Concrete Products of Pottstown, Pennsylvania, created the first pre-tensioning bed to make pre-tensioned bridge beams. Soon came such innovations as the Michigan block beam system, which required only 3 components to produce. The first pre-stressed girders designed for a building were produced in 1951 in Tulsa, Oklahoma, using button-headed linear pre-stressing. That same year, in Tacoma, Washington, Anderson Brothers built their pre-stressing plant. In 1952, Prestressed Concrete of Colorado produced a double T design. Marketed as the Twin T, it was first used for a cold storage warehouse for Beatrice Foods. It allowed larger spans between beams and remains a key component design to this day. The Arroyo Seco pedestrian overpass in Los Angeles marked the first use of pre-stressed concrete in California. It used a post-tension stressing system developed by the Prestressed Concrete Corporation of Kansas City. In Florida, there were innovations such as 60-foot pre-tension warehouse beams, new pre-stressing facilities built by Florida Prestressed Concrete in 1953, and innovative ideas of all sizes and shapes. A variety of bridge designs were created in Florida, spearheaded by the Tampa Bay Crossing in 1951, which sustained the momentum of the Walnut Lane Bridge. During this time, box girders for short spans were designed that took advantage of sonovoids. Testing these box girders in the early 1950s led the Pennsylvania Department of Highways to approve the use of pre-stressed box girders for 6 expressway overpasses in downtown Philadelphia in 1955. The project marked the first ever large-scale application of box girders in the country. Throughout the 1950s, pioneers in the pre-stressed concrete industry continued to expand the material's design capabilities. One was Harry Edwards, president and founder of Leap Associates, a consulting engineering firm in Lakeland, Florida. Founded in 1950, Leap has concentrated its services almost exclusively on the development and promotion of pre-tension concrete and the computerized analysis of pre-stressed concrete structures. Another early innovator was consulting engineer Ross H. Bryan of Nashville, Tennessee. Brian designed the first linear pre-stressed structures in the U.S., as well as the first structures using deflected pre-tension strands. He also developed design procedures for establishing continuity in precast pre-tension concrete members by using mild reinforcing steel. Further west, George C. Hansen, a structural engineer with Phillips Carter Osborne in Denver, contributed design criteria for precast pre-stressed members, from fabrication to construction applications. He also developed load tables and brochures for pre-stressed members. Over the years, continued advances in pre-stressed concrete led to the need for a central organization to unify and advance the industry. An early informal association was created among the first pre-stressing companies. Ultimately, 6 Florida manufacturers joined to form the Prestressed Concrete Institute on June 18, 1954. Those 6 companies were Cone Brothers, R.H. Wright & Company, Durastress, West Coast Shell Corporation, Lakeland Engineering Associates, and Lakeland Concrete. They created 6 classes of members: active for pre-stressed companies, associate for related businesses, professional for architects and engineers, junior for professionals in training, student for those in architectural and engineering colleges, and honorary as designated by the board. Right from the start, PCI's founders recognized they weren't creating just another trade association. PCI would be an organization directed by the active participation of professional engineers. This unique combination of producers, suppliers, and professionals nurtured the growth and vitality of the pre-stressed concrete industry and led it to become what it is today. Douglas P. Cone was elected PCI's first president. George Ford served as vice president, while Harry Edwards was named secretary-treasurer. These men, along with the organization's directors, established 4 objectives for PCI. 1. Develop standard specifications for pre-tension products for designers and engineers. 2. Conduct full-scale fire tests of roof and floor slab products. 3. Develop and promote the standardization of beam sections for bridges. And 4. Produce a technical journal and newsletter. These goals were quickly achieved. PCI released its first industry standard, Specifications for Pre-Tension Bonded Pre-Stressed Concrete Products, on November 7, 1954. As progress continued, the group held its first annual convention at the Lago Mar Hotel in Fort Lauderdale, Florida, on April 21st and 22nd, 1955. More than 300 engineers, designers, contractors, and producers attended. In 1955, PC Items debuted as a monthly periodical. It was followed in May 1956 by the quarterly PCI Journal. Now a bi-monthly, it remains one of the premier communication vehicles of the precast concrete industry. On September 1, 1956, PCI created a permanent headquarters staff when Colonel Martin P. Korn, a former consulting engineer, was appointed PCI Executive Secretary. The organization opened its temporary headquarters in Boca Raton, Florida. 3 years later, the Florida Prestressed Concrete Association was formed to promote the material locally. PCI headquarters moved to Chicago in December 1959, where it remains today. But while the headquarters has remained in one place, the industry has moved ahead with breathtaking speed. Today, architects and engineers continue to advance the industry's capabilities, using new technologies and ideas to stretch design parameters. Recent advances include breakthroughs in seismic techniques that will expand the uses of precast concrete nationwide. Ultra-high performance concrete that will expand the durability of precast concrete to 30,000 psi and beyond. Self-consolidating concrete that will produce higher strength, faster production, and better aesthetics for all types of projects. And all precast bridges with beams, deck slabs, pier caps, and columns. These components can be used to replace bridges on rapid schedules. Where will precast concrete take the construction industry in the next 50 years? The answer lies in the dreams of today's architects, engineers, producers, and suppliers as they continue to stretch the boundaries. Their work will be nurtured and strengthened by the encouragement, promotion, resources, and expertise of the Precast Prestressed Concrete Institute. After 50 years, the best is yet to come, and it begins today.